Good.
Hello, everyone, and welcome to our first completely virtual OWASP Ottawa meetup. My name is Garth Boyd. I'm one of the leaders at OWASP Ottawa, and I'd like to welcome you to this first virtual meetup from the COVID-19 bunker. I'm hoping everyone is safe and sound and everybody's families are safe and well. And with that, I just want to talk a few things about a couple of things from the PSAs that you see. For the first, I'd like to thank Shopify for giving us lots of time to plan and arrange this. They originally saw this very, very early and decided, hey, we need to find another venue because there's going to be issues with people, gathering en masse. So I'd like to thank them for giving us a very early heads up so we can plan and arrange a virtual meetup. The next thing I want to talk about is how you connect to OWASP Ottawa through the usual social, or if it's your thing, anti-social media. We have a Twitter account under OWASP_Ottawa. And a Slack, which you can self-register for at the link at the Heroku app you see on the screen. And of course, because you're seeing this, you obviously already know about YouTube. The other thing I want to mention to you from our list is just a quick shout out to our volunteers who, without their help, OWASP Ottawa would not exist. So next chance you get, send, I guess, a virtual hug to any and all of our volunteers. So with that, I'd like to introduce our speaker this evening. We're very, very lucky to have Rahul virtually on the line from Toronto, who's going to talk to us about that which is choking AppSec and his experience at We45 and his experience as both a builder, a breaker, is a very unique point of view to talk about some of the issues that AppSec find in our new world of DevSecOps. So without any further ado, we're going to try to gracefully hand off the screen share. So Rahul can start off. Welcome, Rahul.
Thanks, Garth. Thanks a lot. Let me just quickly go ahead and share my screen. Just let me know if you guys can see it, and then we should be good to go.
Well, we know you have a Mac.
Are we good?
Yep.
Awesome. All right. So welcome, everyone, and thanks for joining in today. I know, like Garth mentioned, it's a tense situation out there, and I hope all of you are safe, all of you are comfortable, and it's great to probably spend some time on something which all of us love about, all of us like to talk about, and a good break from all those things that's happening out there. But so let's get started, and we'll hopefully have a good, interesting next few 40-odd minutes. So before we get started, just a little bit about myself. Sorry, that just went one. Okay, there you go. So a little bit about myself. My name is Rahul. I'm one of the co-founders at We45. Pretty much been on the building and the breaking side of security for the last 10 odd years. Probably what you see on screen is some of the things that I personally love working on, especially on the application security automation perspective, something on vulnerability management, and more importantly, I was just talking to Garth before we got started. One of the things that I've been personally interested in really talking to product engineering teams in terms of having conversations around return on investment in terms of application security, especially since you've got a lot of talks around automation, around DevSecOps and things like that. So those are some of the interesting things that I've been doing over the last couple of years. With that said, what we're going to be talking about today over the next 40 odd minutes is essentially a topic that's pretty close to what we do here at B45 and personally as well. And because this being the early parts of the year, we've been in March, I thought it'd be a topic that would not just be technical, but also kind of resonate well from a business perspective. I usually, if I'm in person doing this presentation, I'd like to have a quick show of hands in terms of what the composition of the room is in terms of developers, security engineers, and so on. But I'm just going to take a wild guess in terms of composition of the virtual room here in terms of understanding application security from a technology and from business perspective. So what we're going to be doing over the next 40 odd minutes is going to be talking about something that's technical, yes, but something that's more fundamentally in terms of security product management to security project management from that perspective. So if you really have a look at product engineering today, we've really gone a way ahead in terms of what's happening in terms of just getting products out there. Most of us are in agile. Some of them, out of whatever compulsions, they're still in waterfall. And then we've got a third category who kind of stuck in between, called the agile fall, because they're probably in between, transitioning between waterfall and agile. But that said, there's a lot of changes happening in terms of just deployments. You're seeing accelerated deployments in terms of organizations trying to really push the boundaries as far as how many releases they could do. The technology stacks are increasing. We're seeing a lot more microservices. You're seeing a lot more lightweight applications being developed. Testing has pretty much gone through the roof in terms of the number of iterations that people test in terms of just functionality, because obviously every single month you're seeing a lot more releases come out. With that said, there's also dependencies in terms of third-party libraries. It's not that the entire code is developed in-house. There's a lot more dependency in terms of third-party libraries as well. However, if you look at application delivery from that perspective, I'd like to kind of consider application delivery in terms of two unique buckets, if you will. So I usually like to kind of bring about the difference of these kinds of deliveries in terms of taking a comparison of the North American market between the East and the West, right? You have companies in the East, typical Silicon Valley companies who probably have releases that go on every single day, right? You probably have releases, you have extensive rapid releases, like sometimes even deploying 5 or 10 times a day. And everybody talks about Amazon, who deployed probably who had a deployment every once in 11.7 seconds. And that was way back when they themselves moved into AWS. I can only imagine the number of releases that they would have at this point in time. But even if you consider somebody much, much smaller, you have organizations in the product segment who have multiple releases in a day. And then you have companies who are larger enterprises who don't necessarily have the same number of releases per application, but what they do have is they have a large amount of applications, so the inventory of applications are large. So even if each of those applications undergo 5 changes in an entire year, you're talking about 5 changes across, let's say, 2,000, 3,000 different applications. So in terms of just the challenges of application deployment and application delivery, you have these 2 different types of challenge of scale. You either have a scale issue within one category of application where you have changes happening every single day, or you have a scale issue where you have horizontal scale, where you have a large number of applications that kind of change every year, but they probably have a minimal number of changes happening every year. Or you have a combination, right? You have a massive number of applications in this portfolio where few of them have adopted horizontal scale, and 4 of them have the scale in terms of changes that happen per application. And with these releases, you have a lot of impetus on DevOps, right? So obviously, when you're talking about scale, when you're talking about applications that have releases, you really cannot remove DevOps from that equation. So we're going to be talking about all of these different kinds of companies. And and obviously when the presentation is called the Clutter, we're going to be getting to what really that clutter is, because it's obviously with their scale, and therefore you're talking about security and scale. You're obviously going to be talking about a lot more issues that come with the scale, because what happens in reality in terms of what, as opposed to what is theoretically possible in terms of DevSecOps or AppSec automation, there are two different things. That's something that we're going to be talking about today as well. This is usually the most liked diagram of DevSecOps. I know we have a chat channel open, so if somebody at the end of this presentation could really kind of explain to me what this diagram means, that would be really helpful, because I've had this on my presentations for the past 2 odd years, and I haven't made a lot of sense of what this infinite loop really means. So I'm going to kind of usually switch this to a more understandable world of DevSecOps, which really is this, right? So what we have at the top is the traditional view of product development, which has your plan, code, release, deploy, operate, and monitor. And then on the bottom, you have the ideal phases of security engineering, which essentially starts out from threat modeling, goes on with security composition, source code analysis, and so on, right up to security monitoring and attack detection on the right. So our definition at V45, or rather what my personal definition of DevSecOps also is, really this mix of security engineering seamlessly going into product engineering. So one of the things that we've done, obviously, in terms of the color codes, you'll see that it really depends on what activities fit into what angles or what aspects of product engineering. For example, threat modeling is usually an activity that would probably take on the complete plan phase of product engineering and move a little bit into code, whereas your static code analysis is something that's largely relevant only in code and goes on to the whole aspect of build as well, and so on. So it's really this fundamental understanding of where does security really kind of figure into the product engineering model is where you would probably have true DevSecOps and true security engineering kind of starting off. In terms of the current state of security, you see, or obviously see that the DevOps and the DevSecOps movement has picked up, right? So businesses across the plane want to move faster, and they want to go to market faster. And DevSecOps is obviously therefore, amongst other things, on the screen that it has led to. It's also seen an increase in CI, it's seen an increase in tooling, test management, build management, deploys, post-deploys, and a lot of other things within the scheme. And security too has moved up, from a traditional gatekeeper kind of functionality, and today it kind of embeds itself into different pods of product engineering. But all of this means that we're really using more tools than what we're doing earlier, right? So when we were in silos, and the traditional worldview of security probably a decade ago was largely in silos. And now when you're kind of moving away from silos into something that's more organized, you obviously means that you're using a lot more tools. I mean, and when you say tools, it also means a lot more integration between these tools from one unit from another. So today you have DevOps talking to security, you have security talking to development, you have both development and security teams kind of integrating themselves with QA in some cases. So you have a lot more integrations today than what we had earlier. Though some of these numbers kind of really give us an indication in terms of the actual number of vulnerabilities that organizations are seeing. And be warned, these are numbers from 2016 and 2017. I intentionally want to keep these older numbers because even when you look at something that's 3 years ago, you see these numbers that are pretty massive, right? And I always like to look at some numbers that are massive, look back at those numbers, because you only native intelligence tells us that all of these numbers would have definitely kind of skyrocketed upwards. So, and these And this obviously means that DevSecOps is not really it's not really an indie movement of sorts that's just happening in one pocket of the world, and it's just something that others are just watching. It's obviously picked up speed, and these numbers are obviously across some large implementation projects. And with the development and deployment architecture, with DevSecOps, even deployment architectures have also kind of increased significantly, right? So today you have more components to assess than what you had a couple of years ago or even a decade ago, right? You have in every typical infrastructure, in application infrastructure, you had all of these components. So today assessors and testers, the sheer inventory of what they need to assess has tremendously gone up. And if you're talking about scale, if you're talking about continuously assessing these components, you're obviously looking at a lot of information. And when I say information, we're looking at vulnerabilities that really, really come up from each of these tests. And I know for a fact that way back when we started off with the application security perspective, we used a minimum of 3 to 5 different tools to perform a single application test, right? And that was a lot of information that we got from these just one, if you just looked at layer 7 and layer 6 assessments. But then if you're looking at an entire OSI layer assessment and you have all of these components, you have a lot of information that really comes from these components. And that's something we're going to talk about as well. While we'll look at some of these challenges in more detail, I just want to kind of touch upon this very briefly. Obviously, AppSec teams themselves have had some serious constraints in terms of availability. They've had, you hear this very, very often, though we still hear a lot of recruiters saying they have openings for application security professionals, but they're just not able to fill them up. And then you have application security engineers who are saying, look, I've been looking for jobs for a while now, but I've not really found some. So there's obviously a disparity there. But that apart, even AppSec teams that are quite mature, they've been having serious constraints in terms of availability. So the time spent in triaging issues, sorting issues, the constraints that they have through tools, which by the way give out some major inconsistencies. And a lot of us don't know how to integrate security with engineering workflows, right? So you have some of these very, very key challenges that come with this information overload. And the last one that we're going to talk about, and which we'll see in detail, is also in terms of managing vulnerabilities when you have such things coming up in this huge scale. Bandwidth obviously has been the single largest constraint with AppSec teams in the current scenario, right? With businesses really moving agile, they're hiring more developers, no doubt, but alongside developers, they're having more agile project managers, more operations folks, more crowd engineers, but almost no one from a security standpoint. And obviously, this number is not new to the people screen here, right? So on the room here, we've really faced this in terms of any sound or mature product engineering team. And something that we've noticed in a lot of forums such as these is the higher calls that you get for security engineers. And some of them really get to work on interesting product initiatives or product engineering initiatives. It's great. But there is really another side to the story that really goes mostly unnoticed, which is really how a typical security engineer's time is spent. And I'd usually like to take the example of Jason the tester, right? So let's consider this fictional tester called Jason. He works, let's say, as a lead security engineer at a digital product house whose customers are, let's say, in the banking and financial sector, for example, right? So let's get a sneak peek into the typical week of Jason, let's say a couple of months down the line after he joined. So he's now in the organization, well settled, 3 months down the line. So what does Jason's week kind of look like? So the first thing that he's responsible for is obviously security assessments. That's something that was what he's hired for. So looking at applications, performing pen tests, great. Then you're also supposed to give remediation assistance. to developers in terms of the issues that you found. Sure, no problem, you could do that as well. And then for some reason, you're pulled into compliance audits because your organization, because of it being in the BFSI segment, you need to look at PCI compliance mandates, look at SOC compliance mandates, so your time gets dragged there. You need to draft security reports, you need to onboard tools, you're suddenly asked to do threat modeling, and then team decides that you need to get into automations, you're automating tools in CI/CD pipelines, you're validating fixes, you're reviewing vulnerabilities, you're responding to customer questionnaires, security training, and then if you have a little bit of time left, Jason also kind of does a little bit of security research, which if he finds time. Now, this is what typically a security engineer's time is already spent in. Now, on top of this, if the management really asks them to continuously test for security, which essentially is Jason doing this, all of these exercises times 5 or times 10, you're really not going to have the same Jason anymore, right? Jason's going to be absolutely pissed off. He's going to be disappointed, he's going to be stressed, and because it's not really the way to go about things, because you really are seeing a huge dichotomy in terms of available time of security engineers. So what we're going to do today is, though we have all of these issues, we're going to really focus on one single issue here, which is the issue of managing vulnerabilities. And that's really where the clutter comes in. And this really brings us to the core of today's topic, the clutter in application security, which is that of managing vulnerabilities. And I often say that an application security program is only as efficient as managing vulnerabilities, because what really is the point of having all of these amazing tools, amazing platforms, skilled teams, and processes if software vulnerabilities cannot be efficiently generated, or categorized, shared, and remediated, and things like that. And then most importantly, if they cannot be prevented from regressing back to upstream software development, your whole application security program is really quite inefficient, because an AppSec program really needs to start off with vulnerability generation and really go into the whole aspect of vulnerability remediation and preventing it from regressing. And this clutter that I'd like to call clutter is probably one of the most significant reasons, in my personal opinion, that prevent product development and security engineering teams from not being able to kind of bridge the gap between the ideal of what DevSecOps is and the practical of what DevSecOps is. So there's a huge gap between theoretical and what's actually feasible at ground zero. And this also prevents teams from really being able to increase that whole secure product throughput, in terms of being able to consistently get product releases out there with consistent levels of security in them. And we'll dig a little further into some of these things, obviously. But before we do that, I think it's essential that we understand the anatomy of a vulnerability. And this is something that's absolutely necessary for us to kind of really have that perspective of managing vulnerabilities. But before you even understand the anatomy of a vulnerability, we really need to have this in place, which essentially is the difference between CWE, CVE, and CVSS. Now I know this is the OWASP chapter. I know there's a lot of accomplished security engineers here, but trust me, I've been in this domain for a decade, and the number of times, either in an interview or in a security report, that I've seen people really get confused with these three terminologies is not even funny. And for that, there's often an analogy that I like to compare this problem with. And I think CWE, CVE, and CVSS are really like the Baldwin brothers, but without the famous one. Forget the famous one out there, and then you're really stuck with three terms that are very similarly looking. You know the differences, but you really can't put a finger to who is what. And no one really gets the other movies right for the first time around amongst the other Baldwin brothers. And quick fact for people who did not know, the one in the far right is actually a Baldwin brother that I did not know. His name is Daniel Baldwin. So whoever is interested, you can check him back there. So back to CWEs and CVEs. So At the risk of some of the security experts here grinding your teeth, I really have to go through this quick 101. And trust me, this is important when we talk about managing vulnerability at scale. Now, CWE is really, which is called the common weakness enumeration, is really a system for categorizing vulnerabilities in general, right? So it's got over 600 categories, and it includes and kind of includes classes for buffer overflows, path traversals, errors, race conditions, crash-type scripting, hard-coded passwords, and things like that, right? So that's really what the CWE is. And the CVSS, which is the Common Vulnerability Scoring System, is a free and open source standard for assessing the severity of computer system vulnerabilities. So what CVSS really does is it really kind of attempts to kind of assign severity scores to vulnerabilities, allowing security engineers or developers to kind of prioritize vulnerabilities and kind of allocate resources in terms of remediation, things like that. Now, the last one, CVE, which is the common vulnerabilities and exposures, is really I like to call it really like it's really a dictionary, if you will, right? It's got a whole bunch of standardized names of vulnerabilities and other information that's related to security exposures, so to speak. And really the purpose of the CVE is to really kind of standardize the names for all publicly known vulnerabilities and kind of tell them what the security exposures are and things like that. So before we go forward, I think this by itself, and we've kind of written articles about this as well, but it's really important for us to kind of understand these differences, because when we talk about managing vulnerabilities, we really need to kind of understand what are the metrics that we're kind of talking about, and what are the kind of structural differences between what constitutes a vulnerability and what kind of adds a lot of more priority to the vulnerability. So I thought this quick 101 is something that was necessary. So for all the ones who knew this, I'm sorry about that. So tools are great. They make our lives easy. They make security engineers' lives easy, but and they are able to kind of find flaws in a way and approach them and generate the kind of data required to find a lot of these vulnerabilities, but they do have a lot of more inconsistencies as well. A lot of them, open source and commercial, they have inconsistencies. They kind of have inconsistencies in a way that produce this data. Some of them have different names. Some of them have different verbiages for the same vulnerabilities. And most of the tools, most of correlation tools, which kind of talk about these vulnerabilities, most of them kind of rely on CWE, which is what we call, which really is that categorization of vulnerabilities. The problem is a lot of these tools don't give you CWE, including popular open source tools. Like, so for people who use tools like Bandit or Brakeman, for people who work in Python applications. So these applications don't really give you CWEs. So there's really no way to backtrack vulnerabilities from these tools and kind of tie them back to a baseline nomenclature. They don't give you the taxonomy as well. So you don't know when you're looking at vulnerabilities whether this vulnerability is benchmarked against, let's say, an OWASP categorization or a taxonomy, or are we kind of normalizing these vulnerabilities according to, let's say, the SANS Top 25, for example. So you don't really have that. And some of them don't even give you risk categorization, right? So you're left to yourself to kind of figure out what really is the prioritization of these vulnerabilities. So the issue of consistencies is something that's very, very real when it comes to managing vulnerabilities, especially vulnerabilities that come from tools. Now, let's see some examples here. I've got some couple of examples that would kind of drive this point across a little better. So let's say you're running a FAST, NSC, and a DAST, right? So you kind of find SQL injection, for example. There's a good possibility that each of these three different tools call SQL injections in three different ways. For example, OWASP ZAP or BERT might call it blind SQL injection, and the FAST might probably call it, let's say, time-based SQL injection or something else. And you find massive inconsistencies between them. The issue really is while a security engineer might understand the difference between a SQL injection and a blind SQL injection, or a time-based SQL injection, for example, the problem really occurs when the reports go to developers, because from a development perspective, you would agree with me that the fundamental remediation for a SQL injection vulnerability, compare whether or not it is time-based or something else, it's really the same. The way you would remedy a SQL injection from a development perspective is still the same. So do we need to kind of overburden developers with this additional information or non-normalized information in a way? Can we kind of make their lives simpler? And one of the things is for you to kind of ensure whether you're able to take results from 3 different tools or 4 different tools and kind of present it in a way that you can, is there a common factor? And believe me when I say this, because we've tried literally doing this for almost a year when we were kind of building our correlation systems, right? We've kind of tried every combination in the book, trying to map these vulnerabilities. We've tried string matches, we've tried Levenshtein distance algorithms, we've tried ML algorithms, and all of these provide inconsistencies. And what's made worse is when you kind of taken a vulnerability scanner and gives you a CVE, which is not the same as CWE like we've seen earlier, and it does not give you any information on what the actual vulnerabilities are. So this is an example between, let's say, Akinetics and checkmarks. So if you see the ones that highlighted, and these are reports that I've generated from vulnerable applications, nothing proprietary. These are all we ran these applications against applications like we ran these scanners against applications like WebGoat or OWASP Juice Shop and things like that. So if you just focus on the red boxes there, you see that Akinetics, which is on the top with the CWE ID 79, calls the vulnerability vulnerable JavaScript library, whereas checkmarks for the same application, same CWE ID of 79, calls it reflected cross-site scripting _ all client. So if you just look at purely the description of vulnerabilities, it's just completely different. And for somebody, and especially for development teams, even if it's not security teams, I would say that this would confuse a lot of security engineers themselves. They'll have to really look at these two as 2 different vulnerabilities when in fact they're the same. But then when you have this disparity in terms of vulnerability names, you're really kind of losing a lot of time just kind of correlating these. Now, this is an example between AppScan and BERT. Now, AppScan calls CWE 693 as missing insecure cross-frame scripting defense. But then if you kind of look at the one below, it kind of really gives you a very different kind of vulnerability. Oops, sorry about that. It really kind of gives you a different definition of what that vulnerability is. The same thing goes between 2 fast tools, for example. The one on the top is FindTech Bugs, and the one on the bottom is Better Code. And if you look at again, you've got CWE ID of 89, but then the messages or the descriptions are really, really different. So while looking at this independently, when you're kind of looking at this at a silo, it might not really seem a lot of an issue. But then imagine if you're kind of running tools in continuous integration, you're kind of running tools, you're running 1 SAST, 1 DAST, or some of them run 2 DASTs, 1 SAST, 1 SCA. And then you're kind of running all of these things in continuous integration, and you're kind of getting application vulnerabilities in scale. And if you kind of have to take that and give it back to the security engineer for him or her to look at it and then kind of sort it and then come at an understanding in terms of what the true vulnerabilities are before it kind of goes to the developer, it's just a lot of work. And the last one is, again, something very similar between a Node.js scan and a Zap. I will try and share this presentation with the group later, so you can actually have them. You can look at these vulnerabilities in more detail. But the idea really is for us to kind of look at this problem more. So, like I was saying, when this is run in scale, so this is a small build pipe that I created. I actually would have liked to kind of show you guys the output of these results, but unfortunately I have to swap my screen and then I have to go out again. So I won't do that because I don't want to spoil the what we've got going on here. But really, one of the outputs of this was to kind of take the results from each of these tools, and you would see that individually these tools kind of produced a lot of results. I think if I was right, each of these tools independently produced at least 80 to 90 different results. But then more than 80% of them were results that other tools also found. So if you take a result that comes out from Burp, there's a decent chance that 50 or 60% of the same results we found with Zap, but probably called differently. So if they have the CW ID, you can use that as a foreign key reference. You can kind of map them together. But if you don't, you're going to really have a problem mapping it. So eventually, you see that a lot of these vulnerabilities are the same, but called differently. Some of them also have other inconsistencies as well. So when it's run in scale as part of a nightly build or a daily build, there's just so much more issues that are generated. And what you see on the screen here is a very, very simple pipeline involving just a couple of tools that we use to run this against our own capture the flag application internally. But the idea really here is to have a look at these results, not just the type of issues, but also the format in which these results are generated. For example, some of them generate results in XML, some of them generate them in Excel sheets, some of them generate them in JSON format. So there's a difference in terms of the outputs of these tools that they generate as well. So there are some other contributors to the clutter, for example. So the first thing is the most favorite of everybody else is the issue of false positives. And often a lot of them ask me, is there a tool that eliminates false positives? And if there's some vendor out there who's telling you they've got a tool that eliminates false positives, you can just call bluff on it immediately because you really can't eliminate false positives. But what you could do is kind of create a different alternate system for you to probably reduce the clutter that false positives kind of create. We'll get to that slightly later. But just if you just talk of false positives, for example, now something like this is a report from one of our pen tests. And then obviously we've kind of hidden our details there. But this was an alarming false positive because we were kind of assessing an application that just did not have an S3 bucket. But then you had this report come out from the tool that said that it actually had found an S3 bucket, and that's not even an S3 bucket. So I really don't know in terms of what kind of signature some of these tools run on for it to find issues that don't even exist. And I can understand if this was something that was earlier on, but you have these obvious false positives that take on a lot of time of engineers trying to look at these issues. This is an interesting thing. Not all tools give you this, but I don't know, people who work with Burp probably know this. Burp gives you an interesting score called the severity score, or the confidence score. So if you see the confidence score, it says tentative. Now, if tools are able to give you what's called the scanner confidence score, you can actually say with reasonable amount that that particular vulnerability is all right. You can actually spend time in it. But then the problem is that not all tools have this confidence score built in. So you really are left at the mercy of anybody else for them to go ahead and look at whether some issue really exists or not. And that really is the problem of false positives, because the only way to probably look at a false positive from a theoretical perspective or from a practical, even from a practical perspective, is to actually go and see whether that vulnerability is exploitable or not. But for you to actually look at a vulnerability and even spend time in terms of exploiting it, it would really, really help if there was something that would help you at least reasonably detect if something could be a false positive or not. So I think that's a separate industry, that's a separate talk for another day, but then that definitely is something that's contributing to the overall clutter by itself. You also have the issue of prioritization of security. Like we said, not all tools give you the right prioritization. Obviously, when you talk about priority of vulnerabilities from an application security perspective, you would need to not just take the base seriousness score, for example. You would need to take it in context with other parameters, like what is the impact of the vulnerability, or how easily is it exploitable, or rather, what is the kind of impact that it causes to, let's say, data at rest itself. So the prioritization of vulnerabilities is an additional task, and a lot of us who are the security side of the fence would agree that this is also a cause of consistent back and forth between security and development, because in no team would a security engineer and a developer agree on the similar prioritization. There would always be a back and forth in terms of something being graded upwards or something being graded downwards, because there is fundamentally a difference in terms of a subjective factor between what is considered to be severe and what is not. And the least of the things that you could expect a tool to do is to kind of give you a single vulnerability score, because the tools are not going to understand the difference between an e-commerce site and a ticket booking site. It's going to look at both of these from a very similar perspective. So prioritization and severity assignment is something that I believe is extremely critical when it comes in terms of the time that it takes to, in terms of time that it consumes in an ideal security engineer's life. The last one is in terms of remediation strategy. Again, a huge issue for developers in terms of remediations given by tool themselves. I know this is probably become slightly better than what it was earlier, especially with the acquisitions that's going on in the industry today with, let's say, companies like Checkmarks acquiring, I just don't get the name of the top of my head. I know for the fact that they acquired another company that was in the developer security space. And then they, therefore, what happened was the remediation advisories that tools give become better because now they have context. Now they have context of the vulnerability. They have context of the language in which the vulnerability was found, and there are other parameters that come with it. But then you don't always get vulnerability remediations to the T. For example, let's take a look at this. Now, this is a vulnerability that we found, and if you look at the remediation section, it just says fix _52,000. Now, how in the world is a developer or even a security engineer going to know what that clause means? You have, and this obviously I'm exaggerating. This is just not something that you would find every day. But the point really I'm trying to make is, even if you take actual tools, kind of give you those remediation examples, the time that a security engineer kind of takes to look at that remediation and then change that remediation to something that's more feasible, otherwise it's going to be thrown out the door by the development team, and the security engineer is going to have to find an alternative, remediation strategy. So remediation by itself or advisory is something that takes a phenomenal amount of time of a security engineer's time space in terms of conducting security assessments. So how is it that we declutter this? Well, the mantra that I'd like to follow is called find early and fix early, right? So one of the first things, and this is something that probably all product engineer teams would make a lot of sense to follow, is anything that we do in security engineering, if it can just follow the find early, fix early principle. Now, I was part of a program with the product managers at Amazon, and then they were saying that one of the fundamental thumb rules that they decide, even before they take up any feature development for Amazon, is, does it fit in two buckets? Does it make the cost for the consumer cheaper, or does that feature help in delivering the product faster to the consumer? So any feature that they develop in their application has to fundamentally sit in these two product principles. So similarly, if security teams and development teams can really kind of approach any investments or any processes or any initiatives that they take on, whether that helps security teams find vulnerabilities early, or whether that helps development teams fix that vulnerability early. So I think this is a great way for us to kind of, as a community, to kind of approach product security initiatives in terms of the investments, in terms of processes, or whatever it is. So that's, with that in mind, we have some suggestions, right? Obviously, the first one that we talked about is vulnerability correlation, right? Or more so automated correlations. Now, going back to our previous discussions, let's say you have a string of tools in CI that runs on a nightly basis, which means every night you're going to get results across all of these tools. Now, correlation platforms essentially kind of help security engineers triage security issues without having to kind of without having, you don't need JSON to kind of come every once in a while and actually kind of go have a look at these results, right? So you actually have correlation platforms do this by kind of removing some level of workload from security engineers who have to manually look at these results to kind of say, okay, this result is from Zap. It's the same result that comes from Burp. It's just called differently. Let me put it in this bucket. Here's another result from an A. Oh, the SEA has told me, has said it's found a result in line number 3346. But is that the same thing that Zap found? Oh, yes, it was. Then you put it in the same bucket. So things like this. So correlation is something that would definitely, correlation platforms definitely kind of ease the life of security engineers and development folks to a large extent. The other concept is that of security as code. And for the longest time, security engineers have always kind of passed the buck on to development teams to say developers need to understand security. But I'd probably strike that out. And I think security needs to get code. The way security engineering is transforming over the last couple of years is fundamentally dependent on the understanding that security engineers understand code. And today, everything is looking at an as a code model, right? You're talking about testing as a code. You're talking about threat modeling as code. You're talking about deployments as code. So if security engineering really needs to work with product engineering, security needs to kind of get code. And when I say get code, I fundamentally mean that understanding how code works really kind of helps in two ways. One, security kind of understands how applications work. So therefore, you're not looking at applications fundamentally from a tool-dependent perspective. You're kind of looking at more in terms of the under-the-hood scenario. So you really get an opportunity to understand the mechanics of an application. So therefore, the way you would look at applications now is vastly different. You move away from the context of the tool and you kind of get into the context of the applications. That's one. Second, security engineers having an expertise in code allows them to kind of really stitch up these multiple tools together. So if you're looking at platform A and tool A, are there integration capabilities? Can you work with APIs? Can you kind of stitch them together? So there's a dependency with other teams reduces. So there's a lot of other wonderful advantages that security engineering gets just by probably hiring security engineers who understand code, or probably one of the things that we do at V45 is we just hire developers, right? So we don't hire security engineers at all. We hire developers, and it's easier for a developer to understand security because they just need to have bridge the gap of tools and things like that, right? And understand security from an application security perspective. So that's one thing that's worked for us, but others might have various other strategies. But fundamentally, all that I'm saying is going forward, there is a fundamental need for security engineers to really understand code. It also kind of allows security engineers to automate exploit scripts. So for the longest time, automation as a concept has always resided within QA or quality assurance, because for the longest time, we believed that automation was something that was possible only to validate functional bugs that goes into a system, but that's not true. If we can reuse automation capabilities that QA have, whether it's Selenium, whether it's Cucumber, or any other automation script, there's a very real possibility today that you could use an automation framework to automate security vulnerabilities as well. If obviously, at the risk of digressing a little bit, security vulnerabilities will essentially come in three forms. You either have security vulnerabilities that are generated by tools. You have security vulnerabilities that are manually found for pen testers, which has no tool relevance. We are talking business logic flaws. We're talking about purely changing flags in an application that only a trained mind can do. The third category is a combination of tool and the person who's assessing the application. Now, whether it's in all of these forms, you can actually trace back the way a vulnerability was found and kind of mimic that to a certain degree using automation tools. So take the example of a functional bug. A functional bug is essentially somebody trying to traverse through screens, put in values in certain form fields, and then trying to see if A gives out B. Now, the same thing is with security. If a security engineer is able to kind of write a Selenium script, for example, in a way that he or she was able to find the vulnerability and probably, again, I'm going back to understanding code. If that understanding of code was available, you can actually write a full-fledged walkthrough script for you to traverse through various sections of the applications that you had to do to get to a vulnerability and then eventually exploit that vulnerability. So if you have these automation scripts with you, you can actually run them as regression scripts as part of QA, just like how QA would write regression scripts for functionality. Security can kind of add their exploit scripts to QA and then run QA automation as part where security exploit scripts would also be part of that QA automation engine, which is what we talked about. So that's security regression. And then understanding code would also kind of give security engineers that unique perspective to give alternate remediation advisory, because as security, you're talking the same language as development. So if a developer comes back to you and say, you know what, this particular remediation that you said doesn't work for me, you could actually have a conversation and understand why that remediation does not work, and then are we okay?
Yeah, I'm here. Have we still got Scott?
Okay, cool.
Yep, I'm still here.
No, I just thought I lost. Okay, cool. The third one that we talk about is in terms of integrating security and engineering. We've talked about this a lot. We've talked about how this could happen. But then here are some of the ideas that we have in terms of integrating security and engineering from that perspective. Obviously, security teams are used to seeing PDFs as the singular form of security reports, for example, right? So you always have teams kind of send security reports to developers in terms of PDFs. But the problem is these PDFs are not scalable. You're not able to do much with it. You can't integrate with them. You can't work on them. You can't really dissect that to kind of even create. Even an Excel sheet does certain, it does slightly better. But then a PDF is just absolutely useless at some point in time. But the problem is most security teams today even generate security reports, transmit security reports as PDFs.
Excuse me, we can't see your slides. Can you reshare your screen? I think we lost your share when you lost comms.
Oh, I'm sorry. I'm sorry.
Yeah, no worries.
Just 1 second. Okay. Okay. Are we okay?
Perfect.
Awesome. So what I was saying is, sorry about the delay there, but what I was saying is security teams are largely used to seeing PDFs and PDFs being transmitted, but then engineering teams are not on the other side, right? So they're always in the domain of tickets. Everything for them is in terms of tickets. You got a defect, you need to log tickets to that. You want a task for us, you need to log a ticket for that. So when you're talking differences in terms of PDF reports and tickets, obviously there is a cultural kind of integration more than a technology integration that needs to happen first for you to be able to kind of integrate security and engineering. And integration today is really finding that kind of that sweet spot between spreadsheets, tickets, and PDFs from that perspective, right? So we really need to look at integrating security and engineering more than just the technology integration, but really more from a cultural perspective. How is it that we kind of talk the same language? And one of the beautiful things that I'd like to talk about, and somebody once told me, is if security can treat vulnerabilities as defects, that would be the point where you could really kind of get that breakthrough achievement of going through an engineering team and getting them to solve that security issue or getting them to remediate vulnerabilities in the same speed at which they were kind of found. The problem is today, you're talking about vulnerabilities, but developers are kind of looking at them as defects. So you need to kind of really bridge that gap between vulnerabilities and defects from that perspective. And there are some interesting integration points from that standpoint. Obviously, the CI/CD is the first point of integration that organizations started out with. You kind of have all of these platforms trying to integrate with Jenkins and whatnot, which is great. We've seen a lot of companies go down that path. You also have bug trackers, where today you have a lot of these tools, commercial tools have integrations with Jira, where you could kind of raise issues and automatically that gets logged in as tickets, and then it goes to the pipelines and organizations start, and developers really start looking at those vulnerabilities and solving them because they now have Jira integrations, and therefore vulnerabilities also have tickets associated with them. I have personally seen a lot of organizations use Slack and chatbots to integrate with their tooling system. So as soon as you have a vulnerability, you get a ticket raised, and that ticket automatically gets sent over the Slack system to the developers. And then you are cutting that whole communication barrier by another step. Not only does an engineer need to log into a system to see a ticket, you actually have it coming up as part of a Slack channel. And then that obviously creates a much faster turnaround in terms of being able to act on that vulnerability. And finally, you have dashboards and metric dashboards, right? So, I mean, this might be a far-fetched example, but I have seen this in a company in Phoenix, Arizona, where they have the Jira system actually integrate with their HR system, right? So in a very weird way, I was like, why have you done this integration? And they're like, one of our KPIs is to measure in terms of yearly appraisals, is to really measure the amount of tickets that's closed by developers. I was like, so what do you do? So he's like, we just take information from Jira, and then we kind of feed it as one of the inputs that goes into our HR application, and then we kind of see that as a metric coming up. And I was like, you gotta be kidding me. But that apart, if you just kind of look at metric dashboards, you have a lot of business intelligence tools that organizations use. There's a dashboard that the CIO uses, there's a dashboard that the CISO uses, there's a dashboard that individually engineers use. But all of these dashboards to kind of work, you need to be able to kind of have these tools talk to each other. So one of the fundamental things that I would recommend is when organizations look to onboard application or onboard tools, one of the fundamental things that we need to look at is, do these tools have API capability? Do these tools have the capability to integrate with other platforms in my organization? Because gone are the days where tools can be kind of just used in silos. Today, these tools need to kind of integrate. You need to kind of cut down on that barrier of communication, cut down on that barrier of transmitting information from one end, from one person to the other. It all has to be part of the seamless process in that perspective. So dashboards are great, but a precursor for us to having dashboards is for us to really kind of have tools that work in this ecosystem of being able to work with one another in terms of being able to integrate from a technology perspective. With that, that's really a lot of what I had for today's presentation in terms of being able to look at some of these problems that create the clutter. But in principle, and as the last words, one of the things that I want to really talk about is, if we just didn't look at vulnerabilities as vulnerabilities, if you could, yes, vulnerabilities are great. You're talking about traffic indicators, they can give you high, medium, low. But that apart, if we can actually focus on the metadata of these vulnerabilities, then you have a lot of more actionable intel that organizations could take. For example, if you're seeing a lot of vulnerabilities that get generated that can be associated with the architecture and design phase, for example, then it means that probably there needs to be more focus that goes on into, let's say, aspects like threat modeling, for example. If you're seeing more vulnerabilities come in from, let's say, static code analysis platforms as compared to dynamic analysis platforms, which means that there are fundamentally more issues with respect to the way code is written. So probably you can then focus on your developer security program, for example. If you have more vulnerabilities, let's say, coming much downstream from a deployment perspective, then you're talking about environment-related issues. You're talking about deployment-related issues. So I think the point that I'm trying to make here is it's very important today to kind of look a little bit more deeper in terms of vulnerabilities that get generated beyond just the traffic light indicators of what the scores are. And with the technology possible today, with the kind of correlation that's possible today, it's easy for us to automate aspects of high, medium, low, and not really care as much about it, as much as we would need to kind of look at the underlying metadata that gets released from each vulnerability, because every vulnerability has a story to tell. And if you're able to kind of track these vulnerabilities in a way, in terms of how they were generated, you could really kind of have a story in terms of really drawing out parallel ideas or second level ideas in terms of actionable information, actionable data that product managers or security engineers can kind of take in terms of either education or in terms of tools or in terms of processes or things like that. So I think the idea really here is for us to not get bogged down in terms of the amount of data, but try and take steps that we could eliminate that overload and really get to the crux of the valuable information that vulnerabilities kind of generate for us. So with that, I will end my presentation. If there's anybody who would want to contact me, these are my contact information. You feel to kind of connect with me there. And obviously, if there are some questions at this point in time, I'll be kind of happy to take that before let me just stop sharing. Yeah. Who do you got?
Awesome. Thank you very much. It was very interesting. I had a quick question. I noticed there's at least one question in the chat, but I'll start off with mine because I've got the microphone. What I thought was particularly interesting was the Tower of Babel of security tools that you're talking about, in terms of every particular tool has their own nomenclature. And I'm wondering if you're aware of any standards or standards bodies who are trying to sort of coalesce this into some sort of standardized schema.
Unfortunately not, Garth, and that's really part of the problem statement. And what's really happening is there's a lot of refining happening within those three domains. For example, there's a lot of standardization happening within CWE, a lot of standardization within CDSS, within CDE. But really the issue is that there isn't a logical convergence of getting all of these three information and standardizing that. And that, I think that's really because of the plethora of tools that are available. And if you're only using standard tools, that's great. But then you have a lot of security teams use non-standard tools because that really works for them. There are so many tools that security teams develop themselves because that works for their kind of applications, and rightfully so. And they may not necessarily log all that information in a standard form. They may just want, if you're looking at a row set of 10 parameters, not all tools would fill up all of these 10 parameters. You have tools that fill up 3 out of these 10. You have tools that fill up another 4 out of these 10, but not all tools have enough information to fill in all of these 10 parameters. And only if you fill up all of these 10 parameters will you be able to kind of baseline. So it's almost like finding the lowest common denominator amongst 5 numbers. And to my knowledge, there isn't any standardization available from that perspective as yet.
Okay, yeah, because I've noticed that NVD is talking about something called SQUID, and in terms of a common standard for identifying software componentry. And I thought, well, if we can actually have a standard on software componentry, then we should have a standard on naming the vulnerabilities in that software componentry. But that's, I can dream.
Yeah.
The one question in the chat.
But just to.
Sorry, go ahead.
Sorry, just to add to that point of standardization, probably too soon to talk about it, but but we are in the process of defining a library ourselves. And this library, what I can say now is we are in the process of defining a standardized format of being able to pull in results from any tool, and therefore also be able to kind of fill in the missing pieces of that 10 parameter puzzle that I talked about. So if probably in the next couple of months, we may have a prototype of which you can query this engine, and this engine would essentially give you those missing parameters of that's missing in your tool. So if your tool is generating just 3 out of those 10, you can query our database, and the database will fill out the remaining 7 for you. I would probably have more information of it in the months to come, but we're probably close to kind of building something like that at our end.
Right, awesome. So the question from Paul in the chat was, have you tried integrating the security tools in your pipeline with the OWASP Defect Dojo? And if so, any lessons learned?
Mm-hmm. Yes, we have. Defect Dojo was one of those earlier platforms that kind of came up in terms of being able to correlate some of these things. Now, the issue really, I mean, this was obviously full disclosure. This was at a point much earlier, so I wouldn't say that we have had full-fledged implementation expertise with OWASP Dojo. But one of the things that we felt was lacking in OWASP Dojo was, one was obviously in terms of the support that they had for many tools, and what we've seen is no 2 organizations use the same number of tools. So obviously, ZAP is one common tool that most security engineers use across organizations. So any pen tester would have ZAP in his or her kitty. But apart from that, we found it increasingly difficult to kind of find a standard set of a single platform that kind of supported more tools. So unfortunately, Defect Dojo at that point in time didn't really have a support for many number of tools from that standpoint. The other issue with Defect Dojo, again, at that point in time was the capability to be able to correlate results between a SaaS and DAST. So there's a difference between, I usually like to take the example of Excel sheets. In Excel, you could either merge 2 tables together, or you could just, I forget the other name. So you could actually take 2 tables and either just merge them, or you could kind of merge them with logic. The problem is most correlation engine would just take results and just put 2 and 2 together. What we're looking at really correlating between 2 platforms. So Defect Dojo did not really help in security engineers who wanted to compare the result of a DAST and then hedge it against with a DAST, for example. So I think these were 2 things that we saw at that point in time, but I haven't really had the opportunity to play with it in the recent times.
Cool. Thank you very much. As there are no other questions in the chat, before we sign off, I wanted to raise one other point to the audience, in that if anyone is interested in presenting at any one of our meetups, whether it's virtual or once we get beyond the current situation, live and in person, then, and you have an idea for a presentation, whether it's short, middle, or a full hour, you can contribute an entry to our Sessionize app, and the link should be on your screen now. Again, if you have any questions, you can reach out to us on all the usual channels that we've talked about before, whether it's Twitter or Slack, or leaving a comment in YouTube, or reaching out to us directly. And having said that, I want to say thank you again very much, Rahul, for presenting to us. And I hope everybody is well and staying safe, and we'll talk to you next time. So thank you very much.
Thanks a lot. Thanks, Bart.